Hello students, very good morning. Today we are going to solve some topics of Laplace transform. This is the revision. So we already learned about this chapter. So we revise some topics from Laplace transform. So let's start with the definition. Definition of Laplace transform. If f of t is a function of t defined for all t greater than or equal to 0, then integration 0 to infinite e raised to minus st ft dt is defined as the Laplace transform of f of t, and it is denoted by Laplace of f of t is equal to integration 0 to infinite e raised to minus st ft dt. Okay students, so this is the definition of Laplace transform. These are some basic formula of Laplace transforms. If we have the function of f of t and if we apply the Laplace on this function, we get the solution in the form of s. So if our function of f of t is 1 by s e raised to minus at 1 upon s plus a sin at a upon s square plus a square cos at s upon s square plus a square sin hyperbolic at a upon s square minus a square cos hyperbolic at s upon s square minus a square t raised to n. Students, there are two formulas. If our t is whole number, then that is n factorial upon s raised to n plus 1, and if our n is in the form of fraction, then this formula we apply. This is gamma n plus 1 upon s raised to n plus 1. Okay, now we solve three formula, this 1, 3, second and third. We are going to show the proof of this three formula. So let's start with the first, Laplace of e raised to minus at. So first question, prove that Laplace of e raised to minus at is equal to 1 upon s plus a. So dear students, you know about the definition, or we can say the formula of Laplace of function of t, that is integration 0 to infinite e raised to minus st function of t dt. So if we apply function of t, function of t is equal to e raised to minus at, so f of t is e raised to minus at. So after applying this formula 0 to infinite e raised to minus st, keep it same, but at the place of function of t we write here e raised to minus at, because if Laplace of f of t, then in this formula we write f of t, but if we substitute in the place of f of t e raised to minus at, so f of t in place of e raised to minus at dt. Okay, now here the base are same, the power are we add the powers, so e raised to minus st minus at. If we get minus t common, we can write as e raised to minus s plus at dt. Okay students, if we integrate this integral with respect to t, so e raised to minus s plus at, keep it same, so e raised to minus s plus at divided by the multiple of t is e raised to minus s plus a, so minus s plus a, it is in denominator. Now the limit is 0 to infinite. Students, you already know, if we apply the upper limit, e raised to minus infinity into anything is infinity, and e raised to minus infinity is 0. So if we apply the upper limit, our term is 0. When we apply the lower limit, e raised to minus 0 into anything is 0, so e raised to minus 0 upon minus s plus a, e raised to minus 0 is 1, so minus minus plus, and our answer is 1 upon s plus a. The next question is, prove that Laplace of sin hyperbolic at is equal to a upon s square minus a square. Again the definition of the Laplace function is Laplace of f of t integration 0 to infinite e raised to minus ft dt. Here our function of t is sine hyperbolic at. So Laplace of sine hyperbolic at 0 to infinite e raised to minus st. At the place of function of t we write the sine hyperbolic at dt. Dear students, integration 0 to infinity and e raised to minus st, keep it same, but the formula of sine hyperbolic at is e raised to at minus e raised to minus at by 2 dt. If we split this bracket, we can write as 1/2. Here 2 is constant, so we take this 1/2 outside the integral. So 1/2 0 to infinite e raised to minus st into e raised to at dt minus same 1/2 integration 0 to infinite e raised to minus st e raised to minus at dt. Students, again if we solve this first term only, then here if we get minus t common, we can write as, if minus t common, s minus a minus t is common. And in this second term, if we get minus t common, the bracket is s plus a. So after integration of this integral with respect to t, we get e raised to minus s minus a t upon minus s minus a. Same way e raised to minus s plus a t upon the multiple of t is minus s plus a. Here the multiple of t is minus s minus a. After putting the upper limit and lower limit, when we apply the upper limit we get the 0 answer. When we apply the lower limit we get the answer 1 upon minus s minus a. Same in the second term, when we apply the upper limit infinity, we get the 0 answer, but when we apply the lower limit we get the 1 upon minus s plus a. Dear students, after simplifying this term, we get, when 0 0 is omit and 1/2 is common, so 1 upon s minus a minus 1 upon s plus a. After getting the LCM, we get the final answer is a upon s square minus a square. Students, our next question is prove that Laplace of t raised to n is equal to gamma n plus 1 upon s raised to n plus 1 or n factorial upon s raised to n plus 1. Again, this is the formula of the Laplace transform. When we apply the t raised to n in the place of function of t, we get the 0 to infinity e raised to minus st. In the function of t, in the place of function of f of t, we write t raised to n dt. Students, here we assume that the st is equal to x. So the denominator of t is dt, derivative of t is dt, and the derivative of x is dx. And here s is a parameter, that is constant term. So we get the s dt is equal to dx. So here if we write this s in the right hand side, this is in the denominator. So dt is equal to dx by s. Students, here we convert our variable t into the form of x. Okay, here we convert t into the form of x. So we just check what about the limits. So if we put t is equal to 0, 0 into anything is 0, so x is 0. If we put t is equal to infinity, infinity into s is again infinity, so there is no change in the limits. So when we apply this parameter, here the limits are the same, 0 to infinity, e raised to st is x, so e raised to minus x. Here t, if we get t as a subject, our t is x by s, so write in the place of t x by s whole raised to n, and dt is dx by s, so dx by s. Students, here the power of s is n and this is 1, so total s raised to n plus 1. We write the power of s raised to n plus 1 outside the integral. So the remaining term is e raised to minus x, x raised to n dx. So this is the formula of gamma n plus 1. So gamma n plus 1 is 0 to infinite e raised to minus x, x raised to n dx. So gamma n plus 1 upon s raised to n plus 1, whereas greater than 0 and n plus 1 greater than 0. if n is a positive integer, gamma n plus 1 is equal to n factorial. So we can write Laplace of t raised to n is equal to, in the place of gamma n plus 1 we can write n factorial. So n factorial upon s raised to n plus 1. Okay. Students, let's solve one example. Our given function is discontinuous function, and we find the Laplace transform of that discontinuous elementary functions. Okay, so our question is find the Laplace transform of function of t t minus 2 whole square t greater than 2 equal to 0, where 0 less than t less than 2. Students, again the same, we apply the same formula. Laplace of f of t is 0 to infinite e raised to minus st ft dt. Here our function is 0 when our limit is 0 to 2. So when our limit is 0 to 2, e raised to minus st, and the value of f of t is 0, plus when our limit is 2 to infinite, e raised to minus st, and our function is t minus 2 whole square dt. So students, here our first term is 0, so we ignore that first term and just solve the second term. So 2 to infinite, I write t minus 2 whole square first, then e raised to minus st dt. Here we want to integrate this term, and I take this term as a u and this one as a v. So u keep it same. Integration of e raised to minus st is e raised to minus st upon minus s. The derivative of u is 2 t minus 2. Here we just take this power in the front of the function, so 2, and after cut this power 2, we get 2 minus 2 raised to just 1 in between the minus sign. Integration of e raised to minus st upon minus s is e raised to minus st upon minus s into minus s, that is s square. Again the derivative of this term 2 into t minus 2 is 2, because 2 keep it same, and the derivative of t is 1, and the integration of this e raised to minus st upon s square is e raised to minus st upon minus s cube. Now apply the upper limit and lower limit. When I apply the upper limit, here in all the three terms, here e raised to minus infinity, e raised to minus infinity, e raised to minus infinity, so all the three terms are 0 when I apply the upper limit. But when I apply the lower limit, here 2 minus 2 0, first term 0, 2 minus 2 the second term 0, and in the last term 2 into e raised to minus 2s upon s cube. So after simplifying this, minus minus plus, so 2 into e raised to minus 2s upon s cube. Students, let's solve some example by using direct formula of the Laplace transform. So find the Laplace transform of t square sine 2t. So Laplace of t square sine 2t, here apply Laplace of t square plus Laplace of sine 2t. Here Laplace of t square, so Laplace of t raised to n, where n is any positive integer, that is n factorial upon s raised to n plus 1. So same 2 factorial upon s cube, and sine at is a upon s square plus a square. Here our a is 2, so 2 upon s square plus 2 square, so 2 upon s square plus 4. So this is the answer of our first question. Now find the Laplace transform of sine 3t into sine 2t. Student, here in this function there is no sign between these two functions, so we apply here 2s formula. For that I multiply by this function with minus 2 and divide by minus 2. So minus 2s, that is c minus c. Minus 2s is c minus c. So minus 1/2 Laplace of c minus c, 3t plus 2t cos phi t minus 3t minus 2t cos t. Now the Laplace of cos phi t is s upon s square plus 25. Laplace of cos t is s upon s square plus 1. Here in यहाँ minus sign. If I want to remove this minus sign, just interchange these both term. Now students, first shifting theorem, this theorem is most IMP for the Laplace transform chapter. If Laplace of function of t is equal to f of s, then Laplace of e raised to minus st f of t is equal to f of s plus a. So just start with this example. Find a Laplace transform e raised to minus 3t t raised to 4. Okay, so here we want to find the Laplace of this term. When we want to find any Laplace of any term, and in that term, if there are two terms in the multiplied form and one term is exponential term, then first we have to find the Laplace of the other term and then apply the first shifting theorem. Here in this function we have two terms. In these two terms we have one term, that is exponential term. So first we find the Laplace of t raised to 4. So Laplace of t raised to 4 is Laplace of t raised to n, where n is 4. So n factorial upon s raised to n. So t raised to 4 is 4 factorial upon s raised to 5. Okay, so here this is the answer of Laplace of t raised to 4. But we want to find the answer of Laplace of e raised to minus 3t into t raised to 4. So by using the first shifting theorem, Laplace of e raised to minus 3t into t raised to 4. So we just place s, we replace s by s plus 3. Here the multiple of t is minus 3. So replace your s by s plus 3. If your multiple of t is positive, then replace by negative term. But if your multiple of t is negative, then replace by positive. So that is, if it is negative, then write here positive, but it is positive, then write here negative term. Okay, same the next question. Again I repeat this. Here I first find the Laplace of t raised to 4, and in the answer of this, when there is s term, so replace your s by the multiple of t. So plus by replacing the positive or negative term. Find the Laplace of e raised to t raised to minus 1/2, t raised to, here your n is fraction. This is not a positive integer. So Laplace of t raised to n is gamma n plus 1 upon s raised to n plus 1, right? Students, your n is minus 1/2. So if you put my t raised to minus 1/2, so minus 1/2 plus 1, minus 1/2 plus 1 is 1/2. So here 1/2 upon s raised to minus 1/2 plus 1, that is 1/2. Now students, gamma 1/2 is root pi. So write root pi, s raised to 1/2 is root s. Your answer of Laplace of t raised to minus 1/2 is this. But we want to find the answer of Laplace of e raised to t into t raised to minus 1/2. So by using first shifting theorem, Laplace of e raised to t raised to minus 1/2 is root pi, and replace your s by s minus 1 because the multiple of t is positive 1. So we write here root pi upon under root s upon root pi upon under root s minus 1. Thank you students. Students, next time हम रिविज़न करेंगे the inverse Laplace, the remaining topic of the Laplace and the inverse Laplace transform. Okay, if you have any doubt, please contact me. Thank you.